Very good morning, students. Myself, Professor Nikhil Patel, EC Department, LDRP Institute of Technology and Research, Gandhinagar. Today, my online presentation on microcontroller interfacing. It is a semester 5th subject, and the code is EC502. These are the list of topics to be covered during my presentation. First, we go for the basic definition and introduction of microcontroller. Then after, go for the structure of controller, which are the main comparison between microprocessor and microcontroller. And in this subject, we use a VR microcontroller. And in this presentation, we are go for the just introduction to AVR controller and the features of Atmel 32 AVR controller. This is the definition of microcontroller. A microcontroller is a programmable semiconductor device that contains the CPU, flash memory, RAM, ROM, I/O ports, serial I/O lines, timers, counter circuit, and some clock circuit. Also, controller is known as a computer on a chip. Dear students, as we know that the microprocessor having only ALU, timing and control sections, and some register. But in microcontroller, all these three things are inside it, as well as there are memory, RAM, ROM, some I/O ports, some serial I/O ports, some timer circuits, some counter circuit, and some clock circuits are inside in the chip. That's why it is known as a computer on a chip. Dear students, as we know that the microprocessor are used for the general purpose. We use as a general application, but the microcontroller used for the some specific application. These are the list of some applications in that we use the controller. Starting with the consumer electronics product in toys, camera, robots, washing machine, microwave ovens, we use such kind of controller. Next one is the instrumentation and process control. In that we use our CRO, cathode ray oscilloscope, multimeter, the current tester. In that case, we also use the microcontroller. Some medical instrumentation, ECG machine, ECU, check. In that case, we use again this controller. Some communication and the office equipment, as we know, there cell phone, telephone set, answering machine. In office, we use a fax, use a printer. In that also we use a microcontroller. And some multimedia application is there. We for the design MP3 player, personal digital assistant, we use again a microcontroller. And some automobile application are listed here: speedometer, automatic braking system, locking system. We use the microcontroller. There are some advantages and some disadvantages of using the microcontroller. Main advantage of microcontroller is that there is no need of external interfacing of basic component like memory, I/O ports, timer circuit, counter circuit, interrupt circuit, because all these components, memory, I/O ports, counter circuit, timer circuits, are inside the chip. We doesn't require any special interfacing circuit to interface such kind of memory, I/O lines, etc. Another main disadvantages of microcontroller is that it doesn't require any complex operating system, as well as the instruction must be written and stored in the memory. So it doesn't require any kernel, no real-time operating system are required to store this instruction and process this instruction. As far as the cost-wise and design time and the final product application, the cost is very less of microcontroller. The design time of any specific application are less as compared to the microprocessor and any other. There is a main disadvantages of microcontroller is that there is the amount of memory limits the instruction that microcontroller can execute. As we know that the 8051 family, that we use either 4 kilobyte memory, 8 kilobyte memory, 32 kilobyte. If the my program size there is large, some complex algorithm we have to solve, in that case the microcontroller does not having the amount of internal memory are available. We have to connect externally through this. These are the main manufacturing company available in world to design a controller. The Altera, Motorola, Atmel, Maxim, Intel, Panasonic, Sony, Toshiba, Xilinx, Texas. These are the list of company which manufacturing the different types of microcontroller. Uh, this is the basic structure of microcontroller. The microcontroller consists a central processing unit, which is already available in microprocessor. As far as CPU is concerned, uh, there is a memory, I/O ports, interrupt, serial communication, timers, counters, ADC, and DAC circuit are also available inside the chip. In microprocessor, we have to connect this memory, I/O ports, interrupt, serial, ADC, and DAC externally to perform any such kind of application. But in microcontroller, all these things are inside the chip. The bidirectional arrow indicate that we can read as well as write the data from the memory. For we can read the data from input and send to the output. Same way for ADC, DAC, and timers and counter circuits. These are the main features difference between microprocessor and microcontroller. As we know that the micros are used for the general purpose application, but microcontroller is used for the some special task, special purpose application like washing machine, micro oven, toys, and there's some specific application, traffic light control system, etc. Another main features that differentiate is that the microprocessor does not having the inbuilt memory. We have to connect the externally, but microcontroller having the inbuilt RAM, ROM, different types of ROMs are already available in latest AVR controllers. The application of a microprocessor is a PC, modems, printer. The controller application are AC, washing machine, home automation system, traffic light control systems, audio, video processing system. Here the complexity are very much higher than the microcontroller because we have to interface the such kind of peripherals with processor, though the circuit become complex and we require the larger number of instruction to such kind of interfacing circuits. But in microcontroller there is a less complex, less number of instructions because all these external peripherals are inside the chip. As far as the cost is concerned, the microprocessor having the very high cost as compared to the controller. The efficiency is less and the controller have the efficiency more. The architecture wise also microprocessor some kind known as one Neumann architecture. What is actually one Neumann architecture? In one Neumann architecture, the program and data are stored in the same memory, and in hardware architecture, program and data are stored in the different memory. So when we are run on the we are go for the same program, then if we require the data at the same time the programming executed in microprocessor, we wait for the some amount of time up to the when the data are stored, read and write, and then after the program is executed. But in hardware architecture, there is a separate memory are available, program and data memory. There is no clash of when we read and write from the program and data memory. The example of microprocessors are 8085, 8086. It's the Intel processor, and the controller has the 8051. Now go for the AVR controller. AVR stands for Alf Vegan RISC. It is also known as the Advanced Virtual RISC. It is a modified hardware architecture. See here the student, the word hardware architecture. The previous controller, there are so many company design the controller. Some of the controller are the CISC-based architecture, the complex instruction set computer. But this AVR controller, especially RISC-based modified hardware architecture, 8-bit RISC, single chip microcontroller, which was designed by two students, Norwegian Institute of Technology of Ulf Glibogen and Vegard Bullen, and that was adopted by Atmel in 1996. The AVR, one of the first microcontroller family to use on-chip flash for program storage, as opposed to OTP, ROM, EEPROM, EEPROM used by the other controller at that time. Here, the advantage of AVR is the flash memory. There are 32 kilobyte of flash memory are available in Atmega 32 microcontroller. There are some different family of AVR controllers. Go for the Teeny, Mega, Classic, X Mega. The main difference between these families of different AVR is that the pins configuration. The pins are less in the teeny family and the more in the X mega family. Another is the flash memory. The size of the flash memory are very less in teeny family, and we are go further that the flash memory size is very high. And the application wise, the teeny and mega family are used for the some smaller application, and if you are go for the some complex application, then we use mesotic case when we require the large program memory, high speed networking devices connect. In that case we use the X mega AVR controller. In this syllabus of microcontroller, we study special Atmel chip that is known as Atmega 32 AVR chip. AT stands for Atmel. Mega is the family of that AVR controller, and 32 indicates that the 32 kilobyte of flash memory are available. Uh, Go for the CPU. There is again it is a 8-bit AVR. We can perform the 8-bit operation like arithmetical and logical function at a time. The number of pins are available is 40. The operating voltage is up to 5.5 volt, and plus the minimum voltage is 4.5 volt. The number of IO lines, yeah, here see here that there are 32 IO lines are available in this Atmel AVR controller. So if you want to connect LCD, keypad, such sensors, in that case there is enough IO lines are available in this AVR chip. Another main advantage is main features of the communication interface. These are not available in previous oldest controller, but in here there's a we use a JTAG interface, we use the serial peripheral interface, programmable serial USART are also inbuilt the controller, two-wire serial interface, I2C protocol supported, and another main advantage is the ADC module. Here the on-chip 8-channel 10-bit resolution ADC module are available, so we can connect 8 sensors, analog sensor at a time with having the 10-bit resolution. 2:10 is 1.24. There is a high resolution in that. The accuracy is very high. As far as the timers and counter modules are concerned, there are total 3 timers modules are available. Two it's a 8-bit, and one is the 16-bit counter is there for the some application. The comparator is only one. There is a no DSC module inside this AVR chip. The PWM channels are 4. In the PWM channel are specially used for the application when we have to vary the voltage, vary the speed of some motors in there like a fan. Then we use this PWM channel. Some external and internal oscillator are we use either connect externally or internally up to 8 megahertz. The calibrated internal oscillator is there. The program memory type is a flash. We can erase the entire chip, yeah, block wise and register level in that. Okay, the size of flash is 32 kilobyte, and the 10,000 write and erase cycle we can erase up to 10,000 times and write the 10,000 times. The size of static RAM is 2 kilobyte, and the EEPROM size is 1 kilobyte, where we use the permanent program. There are different power saving modes are also available: standby, ADC, noise reduction mode, power down mode, standby, extended standby. The operating temperature of this chip is minus 55 degrees Celsius to 125 degrees Celsius. And register, there are total 32 registers. That's why the risk-based reduced instruction set computing that special the number of registers are very much higher as compared to the previous controller. Here there are 32 general purpose registers are available. The main advantage here, we do not go for the stack because already 32 registers are available, though this reduce the time consuming go over the push and pop the instruction. Okay, thank you student. These are the